Every hour, 73 accidental fires rage out of control in homes and businesses in the United States. Every year, $11 billion of property damage is sustained due to fire. Worse than that, nearly 6,000 lives are lost annually to these infernos. What can prevent this tragedy from occurring? B.F. Goodrich, the recognized leader in thermoplastic technology, has the solution to this devastating problem. Blazemaster CPVC, a revolutionary specialty material for use in fire sprinkler pipe and fittings.
It really is tragic that so much is lost every year to the ravages of accidental fires. Homes are destroyed, businesses are ruined, lives are scarred forever, and all needlessly. In my 12 years as a fire marshal, I've seen countless examples of fires that could have been prevented if only some basic precautions had been taken. Now, I'm not talking about obvious things like keeping matches and lighters out of children's reach or not smoking in bed. I'm talking about fundamental safety issues like the use of alarms, smoke detectors, and sprinkler systems. Current reports show that sprinkler systems alone could prevent as much as 97% of the property damage and loss of life I see every year. One system in particular, called Blazemaster, has been shown to be especially effective. It's an orange CPVC pipe and fitting system that installs easily and efficiently, and it performs when it counts most, under fire conditions. How can I make a claim like that? Let's look at some facts. The first 4 minutes of a fire are critical. How the fire is attacked in that time can mean the difference between life and death. In a building protected by a fire sprinkler system, the fire is contained and controlled. And while some people might think every sprinkler head in a building goes off during a fire, that's not true. The fact is, the 1 or 2 heads at the source of the fire usually control or extinguish it when they are activated. Damage is minimal, and the possibility of personal injury is dramatically reduced. In an unprotected environment, just 4 minutes after the fire has erupted, it's out of control. The building may be lost entirely, and anyone left inside is probably dead. Typically, by the time the fire is reported and the fire department has an opportunity to respond, it's too late. Shocking? Absolutely. And that's why many states and cities are requiring sprinkler systems in all new construction of certain hazard groups, as well as retrofits for older high-occupancy buildings. And that's where the Blazemaster system comes in. Now, I've done a lot of research in the various types of systems and how they perform. Copper, steel, poly, CPVC. I've looked at them all. And Blazemaster is superior in all the important categories. In fire and product tests conducted by Underwriters Laboratories, the Blazemaster system was found to conform to NFPA 13, 13R, and 13D sprinkler standards. In fact, it's accepted by all major model building codes. It gained the UL listing because of its excellent performance under extreme conditions. But there's another factor to consider when choosing materials for a sprinkler system. I know that a decision to require sprinklers can have some serious economic impact, especially for industries like hotels and government, which have high occupancy buildings and need to retrofit with a minimum of interference to their daily business activities. They're finding that they can meet fire code requirements most efficiently by installing fire sprinkler systems made with Blazemaster materials. Marriott Corporation, Holiday Inn, Prudential, and the U.S. State Department, to name a few, have all chosen Blazemaster pipe and fittings for their fire protection systems. Often these systems pay for themselves over a short time due to decreased insurance rates. Besides, how can you put a price on the peace of mind you have, knowing your occupants and their property are protected? And in new construction, the contractor may realize other savings from improved construction alternatives, depending on local building codes. As a fire marshal, I'm the person responsible for making sure your construction project conforms to fire codes. And these days, that may include specifying a sprinkler system. If you're including a sprinkler system in your plans, you want it to install quickly, easily, and efficiently. The Blazemaster system meets these requirements in ways other systems can't. Because it can be fabricated more easily than metal systems, the materials can be delivered directly to the job site, eliminating a stop at the fab shop. And the pipe and fittings weigh a lot less than metal, making them easier to handle during transport and installation. The only special tools needed for installation are a wheel cutter and a chamfering tool. Correct lengths can be cut and prepared on the spot, eliminating saws, threaders, and torches. It's also a very clean product to install. This can be very important in retrofits where damage to decor is always a possibility. With Blazemaster, there's no oil or grease on the pipe to worry about. And cleanup is as simple as lifting a drop cloth when you're finished. The one-step solvent cement used for creating joints goes on easily and speeds up the installation process significantly. This specially formulated cement also reduces VOCs and the odor they cause, making it better for the installer and the environment. Because of the ductility of the pipe, minor adjustments can be made during installation. This can be really important when you're working in tight quarters, like you might find in a retrofit situation. C-factor performance for Blazemaster pipe is superior to metal systems due to the material's resistance to corrosion and buildup on the interior surface of the pipe. This means that a smaller diameter Blazemaster pipe can provide the same flow as a larger piece of metal pipe. The material's resistance to corrosion also means less cost for maintenance and fewer incidents of system damage over time. If all this means a more efficient installation for a contractor, imagine what it can mean to a client in a retrofit application. Hotels, for instance, don't have to lose occupancy because of the speed and convenience of the installation process. There's little fear of damage to expensive decor because the process is so clean. And guests face a minimum of inconvenience because the installation doesn't create any significant noise or odor. I'm confident that the Blazemaster system should be your product of choice for fire protection sprinklers. Like I said, I've read all the reports. In fact, in one case study in Fontana, California, a fire marshal approved 3,000 installations using Blazemaster, then followed up to see how it performed. His records show 26 activations, all successful. Speaking of California, I also understand that Blazemaster piping's ductility make it an excellent choice for applications with high seismic activity. If you're a contractor, an architect, or an engineer, Blazemaster pipe and fittings should make a lot of sense simply because of their efficiency. They install quickly and easily and perform when they have to. If you're like me, you place a high value on safety and the peace of mind you get knowing you're protected. The Blazemaster system is a product that can provide that confidence by virtually eliminating unwanted residential and commercial fires. And that's a good feeling.
When you need the most efficient, most reliable materials on the market for your fire sprinkler system, think Orange. Blazemaster CPVC from BF Goodrich. For product availability or training, contact these licensed Blazemaster manufacturers.
As the fire marshal for my community, my staff and I look at a lot of blueprints for new construction and retrofits. We have to make sure everything meets the codes. Now, over the years, I've gotten to know a lot of the designers as friends. And I have to tell you, I'm very sympathetic to their situations. Take sprinkler systems, for example. They have to design systems that conform to all the codes while allowing for easy and cost-effective installation. Not an easy job. Lately, a lot of companies have been basing their designs on an orange-colored CPVC system of pipe and fittings called Blazemaster. Now, these materials are made from a special compound developed by the B.F. Goodrich Company. NFPA recognizes it as the standard in CPVC technology. As far as I'm concerned, the most important factor is that the Blazemaster system meets or exceeds requirements for light hazard applications, such as hotels, offices, and schools. In addition, CPVC is the accepted system for 1- and 2-family dwellings and residential buildings. And the way the contractors tell it, this is also a very efficient system to install. Listen to what one contractor has to say.
Blazemaster pipe and fittings are quite simply the easiest piping system I've ever worked with when it comes to installing sprinkler systems. The first time we used it, the supplier sent out an expert to train my crew. It didn't take them long to learn how to professionally install a very clean and efficient system. And I might add, one that goes in very easily. Now that we have the hang of it, I wouldn't consider going back to any other type of sprinkler systems. My company deals with a lot of wet systems for high-rise condos and hotels. So one of the first things I want to know is, how do I get the pipe and fittings up to the top floor? With the Blazemaster system, it's not a problem. Because it's so light, my men can carry a bundle of pipe or a box of fittings that you wouldn't even think about with steel. And we don't need any special heavy equipment to move the materials around once we're in the building. We do need to be careful not to damage the pipe and fittings during handling. To keep the materials safe, we usually store the pipe and fittings right in the shipping boxes until we need them. If the pipe has to be stored outdoors for any amount of time, it's a good idea to keep it covered with an opaque tarp or the original packaging it was delivered in. Prolonged exposure to UV light will cause the pipe's color to fade, but will not reduce the pressure capabilities of the pipe. And we make sure we inspect the pipe for damage before we use it. We don't use any pipe or fitting that has been cracked, gouged, or deeply scratched. But let's face it, it's common sense not to use damaged goods if you care about your professional reputation. Because it's so easy to fabricate, we don't need threaders, vice stands, or torches. All the tools I need fit right in my back pocket. I usually carry a wheel cutter, a chamfering tool, a clean dry rag, a tape measure, a small level, and a respirator for use in confined areas. My crew really likes working with the Blazemaster system. It's made their life a whole lot easier. And in every application where we've used Blazemaster, we've finished the job in less time than we budgeted for. The general contractor's happy, the building owner's happy, and I'm happy. What more could you ask for? Let me show you step by step just how easy it is to use Blazemaster pipe and fittings. Once you have all the materials and supplies on hand, the first step is cutting. Cutting Blazemaster pipe is a piece of cake. Some guys use saws designed for plastic pipe, but I prefer a wheel cutter designed for plastics. It gives me a nice, clean, square cut every time. It's important that the cut be square. That way you're sure to get a good tight fit in the socket of the fitting. The next step is to deburr the end of the pipe. This chamfering tool is best for pipes with diameters of 2 inches or less. It cleans up the cut real well and adds the necessary bevel on the outside edge. The bevel helps the pipe slip into the fitting more easily. It also prevents the end of the pipe from scraping the cement off the inside of the fitting. If you don't have a chamfering tool, a file will also work. Just be sure to bevel the outside edge of the cut. Now that you have the pipe cut and beveled, take a clean, dry rag and wipe off any loose dirt, plastic shavings, or moisture. Particles can weaken the joint strength, and moisture slows the cure time. Okay, now you're ready to dry fit the pipe and fitting. The pipe should go in about 1/4 to 3/4 of the way. If the pipe bottoms out too easily, or if the fit feels especially loose, you might want to try another fitting. If the pipe won't go into the fitting, check the fitting to make sure that it's not distorted. Once you have a good dry fit, it's time for cement. Let's take a minute to talk about the whole CPVC solvent welding process. Any good tradesman with a little common sense will tell you that there are certain things you never do, like using a torch around flammable materials. Well, CPVC solvent cement is no different. There are certain steps you want to take to make sure that you and your coworkers are safe. The Blazemaster system uses a new one-step solvent cement that has some obvious advantages. First, since it's a one-step process, you don't have to use a separate primer. Another improvement is that this new cement doesn't have the heavy odor some of the old ones had. Now, this doesn't eliminate the need for good common sense. You still shouldn't work in poorly ventilated areas without some kind of safe forced air system or a respirator. But in most cases, ventilation shouldn't be a problem. You also want to avoid physical contact with the cement. In other words, it's a real good idea to wear proper eye protection and proper gloves to keep it out of your eyes and off your hands. Finally, no smoking. The cement is flammable, so treat it with respect. The cement is applied with a dauber or a brush for pipe up to 2 inches in diameter. For larger pipe, a roller should be used. I like the dauber that's attached to the can's lid because I always know where it is, inside the can. And I know where to put it in between applications, back in the can. The trick here is to remember to use enough cement. Most failed joints are the result of skimping on the cement. When you're cementing the head adapter onto the drop, you also want to be sure you don't use so much cement in the fitting that the excess runs down into the head adapter. This could restrict water flow to the sprinkler heads. Make sure you get a nice, even coating on the pipe over the entire surface, which will go into the fitting. Put a medium coat on the inside of the fitting socket, then another coat on the pipe. This is where experience comes in. After you've cemented a few fittings, you'll have a feel for how much cement to use. Put the pipe into the fitting right away. Don't let the cement start to dry. Rotate the pipe about a quarter turn and make sure the pipe bottoms out snugly. Rotating the pipe into the fitting ensures that the cement is spread evenly on both the pipe and the fitting. It also allows you to make sure the fitting is aligned properly at the connection. Hold the connection for about 15 seconds to give the bond a chance to take. In cold temperature installation, you need to allow for extra set and cure time. Be sure to check the manufacturer's installation instructions. Now, you want to check the end of the fitting. There should be a continuous bead of cement all the way around the joint. If not, pull or cut the fitting off, throw it away, and start over. Remember, it's always better to take a few extra minutes and do the job right than to have to come back later and fix it. If the joint looks good, wipe off any excess cement with a rag and move on to the next one. Let's take a minute and talk about hanging the pipe. You can use just about any type hanger as long as it complies with NFPA standards. Check the manufacturer's recommendations and the NFPA handbook if you have any questions about whether or not to use a certain type of hanger. If the hanger's metal, make sure there aren't any sharp edges that might damage the pipe. Proper spacing of the hangers is explained in the manufacturer's instructions for your installation. If you follow them, you'll be fine. This is especially important for the hangers next to the sprinkler head drops. Make sure that the hangers nearest the drops for your sprinkler heads are providing good bracing against the reactive pressure that will take place if the head activates. In other words, you don't want the water pressure to force the sprinkler head up through the ceiling. Next up are the sprinkler heads. They should only be installed after all the Blazemaster pipe and fittings, including the sprinkler head adapters, have been solvent welded to the piping. Make sure the fittings for the heads have cured for at least 30 minutes to prevent damage to the joint. Before you install the sprinkler heads, check the fitting and drop for any excess cement. This can be done visually or with a small wooden dowel. It's important that the waterway and thread area are free of any excess that may restrict the flow of water to the sprinkler head. Wrap the thread on the sprinkler head 2 or 3 times with Teflon tape to give you a nice seal. Then screw in the head, finger tight. Now take a sprinkler wrench and tighten the head 2 more turns. That's it. You're done. If you're doing a retrofit and the pipe's exposed, you might want to paint the system with a good water-based paint. Or, like I said, there are some really good decorative covers on the market that install pretty quickly. All that's left is cleanup, and that's as simple as closing up your cement can, putting your tools back into your toolbox, and picking up the drop cloth. After the system has had a chance to cure, you'll need to run a pressure test. The correct procedure for testing the system is to fill it with water, then bleed the air from the highest and farthest sprinklers. Compressed air or gas should never be used to test CPVC sprinkler systems. The system should be hydrostatically tested with at least 200 psi for 2 hours. You should check the plans to find out what pressure the system will be maintained at. If it's over 150 psi, you need to add 50 psi to the system pressure to determine the test pressure. Some local codes might require a physical examination by the fire marshal as well. If you find any leaks, mark them, drain the system, cut the damaged sections out, and replace them. Keep in mind, if the system will be subjected to freeze conditions, the pipe must be winterized with antifreeze. A mixture of glycerin and water is the only solution recommended for Blazemaster systems. Well, that's all there is to it. Check NFPA 13, 13R, and 13D if you have any questions about conformance to code. And your community might have certain fire or building codes to take into consideration. Remember, your local authority having jurisdiction has the final word on all sprinkler systems. I'm sure that once you've used Blazemaster pipe and fittings, you'll see what a great product this is. It's easy to install, it has low maintenance, and it's very efficient. I love this product. I'll never go back to any other piping systems for light hazard and residential occupancies.
Well, there you have it, right from the horse's mouth. The Blazemaster system keeps me happy because I know how well it performs as a fire prevention tool. And it'll keep you happy, too.
Blazemaster CPVC, the most efficient, easiest to use pipe and fittings for fire sprinkler systems on the market today. For product availability or training, contact these licensed Blazemaster manufacturers.
Okay, that does it for metal systems. Any questions? No? All right, good. Let's move on to CPVC. Now, as you all know, CPVC is a specially formulated thermoplastic, which is currently being used in everything from plumbing to sprinkler systems. And the facts seem to indicate it's enjoying great success. It's gaining universal acceptance, and its use continues to grow. Now, because of its success in the marketplace, we're going to take a look at a compound developed by the B.F. Goodrich Company. The pipe and fittings are made by a select group of quality manufacturers and are known by the trade name Blazemaster. The NFPA Sprinkler Systems Handbook mentions B.F. Goodrich's piping prominently in those sections dealing with CPVC systems, recognizing its listing and expanded usage. Blazemaster has been listed for light hazard and residential applications in accordance with NFPA 13, 13R, and 13D. It's also listed for use in air plenum spaces, but we'll talk more about that later. Now, in order to obtain these listings, the Blazemaster system was subjected to a battery of 16 different tests by Underwriters Laboratories. These tests included physical and mechanical properties, pressure, and fire exposure tests. Now, before we take a look at some footage, I should say that rigorous tests were conducted to assure the fire prevention industry that CPVC sprinkler systems would perform as intended when installed in accordance with its listing and the manufacturer's installation instructions. Now, the purpose of these tests was to determine the pipe's ability to withstand extreme direct fire exposure conditions and still deliver water to the heads for periods of 10 to 30 minutes. Now, finally, the tests were conducted in a very large room, which slows sprinkler head response time. And this really puts the system to the test. Okay, let's take a look at some footage. In this first test, a 350-pound wood crib is ignited by a continuous flowing heptane torch. The sprinkler assembly has been suspended above the fire source and is subjected to temperatures averaging 1600 degrees. You can see that about 1 minute into the fire, the first head activates. There is an immediate reduction in the fire's plume, and you can see that it has been controlled. Temperatures at this point drop to about 700 degrees, well below flashover. The heptane torch continues to provide flame to the assembly for 30 minutes, the test duration. Now, at the end of the test, the pipe is examined, and it is apparent that no damage has occurred, aside from a slight charring of the pipe's outside surface. A proof test was then conducted, in which the system was pressurized to 175 psi for 5 minutes. This confirmed that no damage had occurred to the material. Now, following this proof test, the pipe was pushed to failure, which occurred at about 1,000 psi, far in excess of the pressure any system would ever be subjected to in the real world. Now, in the next test, a 5 square foot pan of heptane was ignited under another sprinkler assembly. Temperatures for this test reached about 1,300 degrees. At about 1 minute into the test, the first head activated, having little or no effect on the fire due to the nature of heptane. The sprinkler assembly was subjected to these temperatures for 10 minutes, then examined. Again, the only damage to the pipe was slight charring on the outside surface. Now, in fact, I understand that in this case, this same sprinkler pipe assembly was used for 4 consecutive tests of various sprinkler heads and passed all 4 tests, totaling 40 minutes. All in all, a very impressive performance. The pipe was also tested dry in a Steiner tunnel to determine its suitability for use in air plenum spaces. The bottom line is that it far exceeded both optical smoke density and flame travel requirements as defined by NFPA 90A. The determination was that Blazemaster is perfectly safe for use in plenum spaces in accordance with NFPA 90A. Now, in order to retain the UL listing, B.F. Goodrich and their team of manufacturers had to submit to follow-up tests. These are conducted unannounced on random samples taken directly from the manufacturer's plant. The material is subjected to physical properties tests, such as vice crush, drop impact, and a quick burst test, to ensure that the materials meet the same quality standards as they did during initial testing. All right, let's take a few minutes here to address some issues that have been raised concerning CPVC sprinkler systems. First, you all know about the burn characteristics of plastics. If you apply a flame, they either burn and give off smoke and gases, or they char. Well, CPVC chars. The charring acts as an intumescent, preventing burn-through of the pipe. The same property also means that CPVC cannot propagate or sustain a fire. And as you've just seen, CPVC also has an extremely high limiting oxygen index of 60, which simply means it will not support combustion without an ignition source. Most building materials in use today have LOIs of 21 or under, making them quite flammable. Now, because of its high LOI, CPVC can never be the source of ignition for a fire. In addition, as we saw in the UL tests, it doesn't participate in flashover, which may occur at temperatures as low as 900 degrees Fahrenheit. Now, I know a lot of firefighters have questioned whether or not CPVC is toxic under fire conditions. Let me just say 2 things. First, according to the state of New York, CPVC is less toxic than Douglas fir, or than just about any other building material in use today. And second, we're talking about a fire containment system. And the fact is, this system is so effective, it will actually help control emissions of all kinds by controlling the fire. All right, let's talk for a moment about some design-related issues. Because of its physical characteristics, CPVC will expand and contract with extreme changes in ambient temperature. For that reason, expansion and contraction loops should be incorporated into the designer's blueprints, especially where long straight runs of pipe are to be installed. Now, another question that comes up frequently is the transition between CPVC and metal systems. This might occur, for instance, at the junction between the sprinkler system and the main water lines into the building. Let me just say that there is a wide variety of fittings available for transitioning between CPVC and other materials, such as steel and copper. Finally, let's talk for a minute about fire stops. Whenever a contractor penetrates a fire-rated wall with fire sprinkler pipe, he has to restore the wall to its original rating. UL has tested CPVC with numerous systems and has found that they can achieve a 2-hour rating. When you take all this into consideration and add to it the fact that Blazemaster installs quickly, easily, and efficiently, it seems like the logical choice for light hazard and residential applications. Okay, any questions?
For product availability or training, contact these licensed Blazemaster manufacturers.